So this demonstration is supposed to explain the notion of open sets in a metric space. So we've got these two subsets A and B here, and they're both disks. But this A has a kind of fuzzy edge that's supposed to indicate that it's an open disk. It's defined by a strict inequality. The distance from the center is strictly less than the radius. Whereas the B, this kind of has a hard edge. That's supposed to indicate that it's defined by a weak inequality. Points in B are distance from the center is supposed to be less than or equal to the radius. Now, if you've got any point in A, then we can surround it by a disk, positive radius that's contained wholly in A. That's what's the definition of an open set. If we go close to the boundary of A, then we have to make the disk smaller and smaller to have a disk that's still centered at the point we're looking at and is wholly contained in A. But we can always do that. We can make the disk smaller and smaller as necessary as we get closer and closer to the edge. And we've always got a disk of positive radius around any point in A that's wholly contained within A. But it doesn't quite work with B, right? You see, it works for most points in B. This point here, we've got a nice big disk around this point that's wholly contained within B, and we can do that at most points. As we approach the boundary, then we have to make the disk smaller and smaller, and it still works. But if set B, the points that are actually on the boundary, they still count as elements of B. And if we've got a point on the boundary, then we can't draw a disk centered at that point that's wholly contained in B. Okay? For any points in the interior of B, we can do it, but for points that are actually on the boundary, there's no way to draw a disk of positive radius around that point that's wholly contained within B. And the difference, of course, is the points on the edge, they count as elements of the set B because the set B is defined by a weak inequality, or a less than or equal type inequality. But for the set A, that's defined by a strict inequality. The points on the circumference, they don't count as elements of A, so we don't have to draw a disk around them. The condition is only that for a point that's actually in the set, you have to be able to draw a disk of positive radius. So the set A is open, but the set B is not.